Good afternoon, everybody. How are you today? Sorry, I will not be at school today. I am taking care of sick children, but I'll miss you guys, and I can't wait to see y'all tomorrow. Since I will not be in class today, I don't want to continue with our lesson of we started yesterday with the exponential growth and decay. Today, I actually want to spend some time on something called the failure mode analysis. What I want for you guys is to start thinking like an engineer. Okay, what we're gonna do is I'm gonna explain this to you. When I worked at the plant in Juarez as a manufacturing engineer, one of my functions was to analyze quality control problems or quality control issues. So when we'd send out bad parts to our customers, or when we would make a ton of bad parts and lose money. When we had problems with the machine that made bad parts we could not use, or worse, when we accidentally sent out defective parts to our customers, we had to figure out, first of all, what did we do wrong? So what was the failure that actually happened? Why did we do it wrong? How did we let that happen, or how did our process let that happen? And then how will we avoid making the same mistake? So what are we going to change, or what are we going to update, or what new safety protocol will we put in to make sure that we don't have any commit that mistake anymore? This is what a failure mode analysis. It's really just looking at your problems, looking at the mistakes that were made, trying to figure out what define what the mistake actually is, why it happened, and how you're going to avoid it. Okay? For you guys, what it's going to look like is I want you to look, we're going to look at some problems that the most students missed. So I looked at the data, I looked at the test results, and I saw, okay, which problems did like almost everybody miss, or more than half the students miss? In order for us to grow and learn, we have to look at our mistakes and we have to learn from them. Everything you do in life, it doesn't matter if it's math or your job or your work or sports or athletics or whatever, you are going to make mistakes. You have to get comfortable with accepting that mistakes are going to happen. And you also have to start getting comfortable with looking at those mistakes, really looking at those mistakes and seeing how you can learn from them. That's all failure mode analysis is. And that's all you're going to need to do to try to help you figure out what you need to do so you don't keep making the same mistakes. So as far as the test goes, I want to look over those problems that I found that the students missed the most. I'll provide the solutions or the explanations, and I want you to write them down in your notebook. As I'm explaining the solutions here on the video, I want you to write them down in your notebook. In order for you to grow, you have to understand why you did not get the correct answer. You have to understand which areas you need to focus on. Did you not get the correct answer because um, you set up the problem correctly, but maybe you made some math mistakes? I've noticed a lot of people over the last 2 days where we're taking the exam that they set up the problem correct, but we just had issues with adding and subtracting negative numbers or multiplying and dividing negative numbers. That's little basic baby math that we need to make sure we carry over into what we're learning that's new. If we have struggles with these baby maths, we have to start using the calculator for every little operation that we're going to check on, especially on the exam, until you get comfortable doing those problems on your own without making a mistake. Some of you, the problem might be that there was some detail or some little part of the step or some little process that you missed because either you were absent that day, we covered it in class, you missed one section of the notes, or you missed one little part. Maybe you were distracted, or you might have been on your phone, or you might have stepped out to the bathroom, or maybe you were thinking about something else I explained, and when I explained this part, you might have not heard it. So for a lot of you, you get most of the problem right, you get most of the setup, but then there's like these little details that you're missing, and that means that you need to work on taking really really good notes and paying really close attention to the details. And then when you don't understand something, that you ask a lot of questions so I can make sure I go over every step with you. Some of you struggled because maybe you missed a lot of class, or when you are there, you're just not paying attention, or you're not taking good notes. You might understand the concepts in class, but once you do it on your own, you kind of get lost. And that happens a lot to a lot of students. So these are kind of some of the ways that you might be making mistakes, or not getting problems correct. What I need you to do is think about that and see what area do you want to focus in order to improve for the next exam and for the next assignments coming up. Okay, so let's go ahead and get into the problems. I do it this way, and I want to do it this way because, like I said, this is the engineering mindset. This is the problem solving mindset. This is not just going to help you with math, but it's going to help you in your other areas of your life, including academics and athletics and personal stuff and whatever. How do I get back here? Okay, so start thinking like an engineer. Let's start looking at our problems. I know when I first started at the plant, I was so nervous and I did not like doing this because basically it was like people would come down and look at all the mistakes that I had made when I was setting something up, or all the mistakes I had made when I was designing something. And it's very, very frustrating, and it can be very upsetting to have people just kind of basically like pointing out all the things you did wrong. But if you can start practicing doing this for yourself and getting comfortable with the idea that, you know what, man, like I made a mistake and it's okay as long as I fix it. If you can get comfortable with that, you're going to really, really be able to get going somewhere. Okay. So let's take a look at the first one. I know everybody struggled with this. I even tried to help you guys out and give you like half the answer. But at the end of the day, we still had a lot of students. More than half missed this problem. So I'm going to explain it a little bit, and then I'm going to tell you what I'm going to do about this problem at the end. Excuse me. So the first thing is we have to understand what we're talking about here. This is another big problem for some students. We don't read the question properly, or we read it very fast and we don't really understand what it's asking. So we need to read the question. Given the graph of the polynomial of all of this, match the polynomial's function's graph to the appropriate zeros and multiplicities. So from this, what I can gather is that I'm going to be doing something related to, I need to understand that I'm going to be doing something related to zeros and multiplicities. So when I go into my brain, wherever I store my little files or my notes or my memories, I need to remember that what are the zeros? Zeros are also the x-intercepts or the roots. And those are the points at which the graph crosses the x-axis. It's a very easy definition. So if we look at this graph, we see that there's 2 points where it touches or crosses the x-axis. The other thing that we need to go back into our brains and try to remember is, what do the zeros mean? Like, how do we find the zeros? The zeros come from the factors. So when you have the factors of some problem, when you have like this times something else, all of those are going to give us the smaller components that make up the bigger equation. Okay, the factors are like the smaller pieces that make up the big equation. And the way we get the zeros is that we set the factors, let's say whatever number that is, could be 8. We set them equal to 0. Whatever the factors are, we set them equal to 0, and that's how we find the roots. Okay. So for example, if the x-intercept of the root is 1, 2, 3, 4, 5, and the other root is at -1, those are the roots or the zeros. So we have to understand that the 0 equals -1 and 5, or the roots or whatever. The way we get that is by setting the factor equal to 0. And the factors are like this. X plus 1 equals 0. Let's do it this way. X plus 1 equals to 0, and x minus 5 equal to 0. So clearly these are two of the factors from this graph. Just by looking at it, we know there's a solution at -1 and there's a solution at 5. But that comes from the factors. The way we get the factors is by setting it equal to 0. So if we look at this equation, we could say, what does x need to be for this equation to be true? What does x need to be so that when we add this and this, we get 0? Well, we know that x will equal -1. -1 plus 1 equals 0. And same for the second. If we look at the other 0, what do we have to add to -5 to get 0? Well, we know x has to be 5. If x is 5 and then you subtract 5, that gives us zeros. So that's kind of like the concept that we need to understand. We need to know, what does it mean? We say zeros and we say it's the same thing as the x-intercepts and the roots, but we didn't understand that the way we get the zeros is by setting the factors equal to 0. We set the factors equal to 0 right here. Then we get the roots. Okay. So these are the roots, but these are the factors. And that's how we get these points on the graph. So we know that a root or a 0 There's one at -1, and there's another one at 5. There's -1, and there's 5. There's no -2, and there's no 0. So in other words, this graph is not crossing this x-axis. Does not cross at -2 or 0. So we can say that those are not zeros. For sure, we know those are not zeros. So that's half the answer. That's what I helped you guys out with in class. The next step we need to understand is, what are the multiplicities? Well, the multiplicities were the degree of the roots. Okay, it was the degree of the roots, and we had that in our notes. We also have to understand that if the multiplicity or the degree or the power, the exponent of the root, the power is even, then the multiplicity or the graph, if the degree is even, then the graph is tangent to x-axis, which means it touches but it doesn't cross. And if it's odd, then the graph crosses x-axis. So we don't know what all of the roots are, but we know that 2 of them for sure, based on our choices. Two of them are going to be x plus 1 and x minus 5. Now what we need to figure out is what is the power of the exponent here. And we can tell that based off the graph. So for 1, for example, we look over here, we know it's tangent to the graph. It touches x, but it doesn't cross. So the multiplicity is going to be an even number of the choices given. 1, 2, or 3. Which one of those is an even number? There's only one that's even, which is this one. So that would have been the answer for that. You know that no matter what, it's not going to be 1 or 3, because the graph says it's a tangent, which means it has to be an even number. So we're going to choose a 2 here. Okay. Now for the 0.5, we know that it crosses here at the x-axis. It actually intersects, so it has to be odd. Now which numbers are odd? Well, 1 is odd and 3 is odd. So we need to figure out which one. Is it 1 or 3? Now really, I don't know if there's another way. There could be, but the only way I know out is to get the factors of this whole equation here in order to figure out what the degree is. You can tell that it crosses at 5 simply, you know that it's going to be an odd multiplicity, but you don't know if it's a multiple of 1 or if it's an exponent of 3. And because I don't think it's fair that they didn't give you the factors to this very long equation that's pretty tough to factor. I don't know, you spend 20 minutes just trying to factor that. I'm going to go ahead and give you guys extra points for this problem. I don't even know if it's 1 or 3, but I know it's going to be one or the other. I'd have to do some work to solve it for you, and I don't have the answer key readily available. But it was either 1 or 3. Some of you got it right, some of you got it wrong. But I'm going to give you guys extra points if you at least got this, and this part, because those you should have been able to figure out from what we learned in class. This part, this number 5, would have been a tough one for everybody. So I'll give you guys some extra points there. Let's get to the next problem. This one was I thought it was pretty straightforward. I thought I gave you some examples of something like this, but on the review, but maybe I didn't give you guys enough practice. But it says drag and drop the correct answer. Find the polynomial function with the leading coefficient of 2, a degree of 3, and zeros at -1, 2, and 3. Use the following format to write your polynomial. So what it wanted you to do was it wanted you to follow this form. So the first thing that we need to do when we're thinking about these exams, these types of questions they're asking you and the way they're asking them is to prepare you guys and help get you ready for any exams coming up that you'll be taking, like state exams or PSAT or SAT. They don't just ask you questions flat out anymore. They have you do them in these kind of different ways. So they want you to get from this question as you read it that they want a particular format. They want you to answer it in this very specific way, right here in blue. And then the way you're going to answer it is by dragging and dropping these little tiles into the correct spot. So you need to figure out what information is going to go into the solution, and then you need to figure out which little tiles you're going to bring down. So there's like a couple of things going on here. There's first, you have to know how to do the problem and solve using the stuff we learned in class. Then you have to figure out that they want it answered in a very specific way. And then the last thing you need to figure out is how to actually submit that answer in the way that they want. Okay? So we're going to keep practicing with problems like this, and I'll try to give you guys some more work in class that's similar to how the tests are going to be. But based on the information, we can say that we know have a coefficient of 2. So coefficient, I want you to write this down in your notes. The coefficient is the number, it's only the number. Only the number in front of each term. Only the number. So we don't include the letter, we don't include the exponents or anything like that. We just include the number. Now the leading coefficient is the one that goes in front of the first term. Okay. So we know we're going to have a 2 in front, so we should grab this tile, bring it down here to bring 2. So it should be a 2. Okay, the next thing is we'd have a degree 3. Once I figure out the second part, or the third part, I find out that I actually don't need the degree 3 to answer the question. And then the third part is it says we have zeros. We have zeros at -1, 2, and 9. We know that the zeros are the points on the graph where there's a solution. So there's one at -1, there's one at 2, and there's one at 3. But remember, in order to get the zeros, we have to set the factors equal to 1. So if x is equal to -1, x is equal to 2, and x is equal to 3, in order to get the zeros, we really have to just bring this number back to the other side, so it's equal to 0. So this becomes x plus 1 equals 0. This becomes x minus 2 equals 0, and this becomes x minus 3 equals 0. So again, let me write this here in a different color. The numbers are the roots. These are the factors. So if it wants us to write first 0 at -1, we know that the 0 at -1 is x plus 1. So we should bring this tile and drop it there. The next thing it wants is a 0 at 2, and we know the 0 at 2 is actually x minus 2. So that should have gone over here. And then the last thing it wants was the 0 at 3. So we know the 0 at 3 is actually x minus 3. So we should have dragged this one over here. Okay, that was all we had to do for that one. But in order to answer it, you had to have like you had to know how to do like 3 different things here. Okay. This one, we didn't go over graphing a ton. I think we only spent one period on it, not even a whole day, just one period, which is probably about 35 minutes or so. But the best thing you could have done for these is rational functions. When it shows you, it says a rational function is shown below, which graph best represents f of x. The best thing to do is graph it. You can always graph it. It's so easy to get the information from a graph. So go to Desmos.com, graphing calculator, and all you need to do is type in your equation here. So 2x minus 6 divided by x squared minus 9. 2x minus 6 divided by 2x minus 6, all of it. Let me write parentheses. 2x minus 6, all divided by x squared minus 9. Check to make sure I type that in correct. Let's get my mouse here. Two x minus 6, x squared minus 9. All I need to do is figure out which graph it looks like. So if we look at here, what we can see is that this graph and this bottom half of the line, they like get really close to this line here, but they never actually touch. That line that it's approaching is -3 right here. So all I have to do is look for the graph that has something similar there. This is the predominantly two choices that I saw. People were either picking this one because we saw the asymptote at -3, but we didn't pay attention to the horizontal asymptote, which according to the graph should have been at 0. So this was the correct answer. There was one other option that people chose, and it was actually one of the other graphs looked like this one. It looked like this one, but it had a little circle point right here. Okay. That circle point indicates that there's a discontinuity at that point in the graph. Okay. It looked like this, but it was like this graph. Indicates that there's a discontinuity, which we don't see in the Desmos graph. And because we don't see any discontinuities here at the 2, that wasn't the choice either. So the correct answer was not this one, and that was a common mistake that people made, was that they saw the -3 asymptote right here. Let me write that in different color. What? Let me try this again. Okay. We recognize that there's an asymptote here at -3, and we chose this graph, but we didn't recognize that there was this asymptote here at -3 did not match up with the graph from Desmos, which was at 0. The other error we made was that there was a choice that looked like this, but we did not have that continuity, so people chose A without realizing that that little circle meant there was a discontinuity. When in doubt, graph. Graphing will almost always give you part of the answer, or if not the whole answer. Okay. The last one I wanted to look at was something similar. We hadn't really covered this a lot in class. We covered the vertical asymptote. I talked about what the asymptote is. You should have learned this in Algebra 1, but we didn't get a lot of chance to review. But if you would have graphed this, and this, and this, and then this, you would have been able to recognize really quickly which one does not have a horizontal. So basically, 3 of these will probably have a horizontal asymptote, and only 1 will not. So even if you didn't know how to figure it out using the rational function topics and concepts that we learned, you can always graph it and try to see if you can find the answer that way when you're in a bind. So let's take a look here. Start just writing all these equations. When in doubt, just graph them. X squared minus 2 divided by x to the power of 3. Okay, so that, let's see, x squared minus 2. Okay, let's try the next one. X squared minus 2 x to the power of 3 minus x plus 7. So I know it's tedious to type in all the answers, but if I just do it a little bit kind of quick, and I'm pretty steady in my progress, I should be able to find an answer for this in just a couple minutes. I could have moved on to the next problem. Okay, the green one definitely has a horizontal asymptote. So does the blue. And then that last one. Hey, what happened? Let's correct this. 2x squared minus 2x minus 3 divided by x squared minus 8x. Oh, now that's a lot of mess. Which function has no horizontal asymptote? There's a way to hide this. Okay, so let's see these. Is there a horizontal asymptote? We have to zoom way out. So this is kind of a tricky question, because if you do in decimal, you got to zoom way out to see that right along here at 10, there is a horizontal asymptote. Okay, if you would have just left it the way it was and just look at this little part, you'd be like, what the heck? That doesn't make any sense. So sometimes we can remember to zoom in or zoom out and check out the whole graph as a whole. So at negative 10 here, coming across the y-axis, there is a horizontal asymptote. So it's not going to be that one as a choice. Let's go back here, and I'm just going to draw a little X. Where's my files here? I'm going to draw a little X because that's not a choice. Okay, let's go back to Desmos. Let's see this one. Okay, again, see going along the zero axis, that asymptote's right at 0. Those lines get really close to 0, but they never touch. So that's not a choice. Or not this one. I'm going to close that. I got to go back to this one. It's not that one. Okay, now let's go to this one. Ooh, that one looks kind of... There's like this weird hump. See here, it doesn't quite asymptote. It's got a little hump and then comes down. Maybe that's a possible... Let's zoom out on these. So for sure your answer has to be it's got to be one of these two. I think it could be either one. That's a tough one to answer, because it looks like this one doesn't have an asymptote. I mean, we do on this side, but not on this side. So the asymptote has to be on both sides. And then the red one, same thing. It asymptotes individually here at this point, but not really here. So I think the answer is going to be A. But since it's not really clear and it's really hard to tell, and we didn't go over these too much, what I'm going to do is give you guys a little bit. It's got to be one of these two. I think it's A, but it's hard to tell, and we didn't really go over these too much in class. So what I'm going to do is give you guys, if you got this one wrong, I'll give you some extra points here for this problem. But the goal that I want you to understand is that if you are in doubt and you can graph it, at least with this problem, you could have eliminated 2 choices, and you would have been down to 2 choices, and you could have had a better odd of guessing the right answer than when you just guessed among four guesses. So that's one technique, one trick that you can use when taking some of these exams. Okay, we'll start going over the exponential growth and decay tomorrow. I hope you guys learned something from reviewing your test and kind of going over these solutions. I'll see you guys tomorrow, okay?